All right, Matthew, here we go. We got lesson 2.1.2, flowcharts for congruence. And we already have done things like this back in Math 1. So last year you should have done some of this. So we're going to go a little bit further this year. So here we go. We've got two triangles here. And it says, how are the triangles congruent? Make a flowchart. So we can see here that we just have a bunch of numbers on here, but I can see that AB is congruent to FD because they're both, 6 units long. So those two are congruent to each other. I can also see that BC is congruent to ED because they're both 4.5 units long. And finally, I can see that AC is congruent to EF because they're 7.5 units long. So based on what I have here, I can tell that I have side-side-side congruence. So we're going to prove the triangles are congruent using a flowchart. Let's start. So the first thing that we need to do is prove that they're congruent. Remember, congruence means that all the sides are, or the measurements are equal to each other. So I'm going to start with saying that AB is 6. So I'm going to start and say AB is 6, so that the length of AB is 6. And I also know the length of FD is 6. So I'm going to say FD is 6. So those are my first two statements. And both of them were given to me. So I'm just going to write given for those. Then on the next sides, the BC and the ED, I'm going to say that BC is equal to 4.5 and ED is equal to 4.5. And those, of course, are given to me. Lastly, I'm going to say that AC is 7.5 and EF is 7.5. So AC is 7.5 and EF is 7.5. And those are also given to me. All right, now remember when you are writing a flowchart, you need to, or not a flowchart, when you're doing a proof for triangle congruence, you need to prove 3 things are congruent. We haven't written down the congruent symbol yet, but we can start writing down congruent symbols because I know that since AB is 6 and FD is 6, well, that means they're congruent to each other because they have the same measurement. So now I can say that AB is congruent to FD because they both have a measurement of 6. So basically these two statements together flow into the next statement to say that since they have the same measurement, they're congruent to each other. And I can do that with the other 2 pairs of sides. I can say over here that BC is congruent to ED because of these 2 statements. And finally over here, I can say that AC is congruent to EF because of these 2 statements. We said that they have the same measurement, and that means they're congruent to each other. So we have to write a reason for all these, and it's just going to be the definition of congruence. Congruence means they have the same measurement. We proved they have the same measurement, so they must be congruent to each other. That's the definition of congruence. I'm just going to abbreviate here because there's not a lot of room. So definition of congruence for each of those. Okay, so now I have this side, these 2 sides congruent, these 2 sides congruent, these 2 sides congruent. That is side, side, side congruence. I can now say, because of these 3 statements, that these 2 triangles are congruent to each other because of side, side, side. So I'm going to start with this first one, and I'm going to say triangle ABC is congruent to triangle. Now A is between 6 and 7.5, and F is between 6 and 7.5. So in our congruence statement, we have to match up the corresponding parts. B is between 6 and 4.5, D is between 6 and 4.5, so D comes next. And then finally C is between 4.5 and 7.5, and that goes with E. So there I have my congruent statement. All my letters are in order. I was able to state that because these three statements flowed into it. And now I can finally say that the two triangles are congruent by side, side, side congruence. If the three sides are congruent, then the two triangles are congruent. We don't need to prove the angles. All right, next one. On this one, we've got a side here already done for us. It's 6, and that corresponds to this side over here that's also 6. Then we've got this angle here and this angle here. They're both 120. Now, I only have two things. I always need three things to prove they're congruent, and they only gave me 2. But I can use my other angle properties that we've been doing in Unit 1, and I can see here that I have vertical angles. So this angle here should be congruent to this angle here because they're vertical angles. And now I have three things. And this is angle, angle, side, because the side is not in between the two angles. We would call this angle, angle, side instead of angle, side, angle. So angle, angle, side, the side's not included. It's not in between. So it's angle, angle, side. All right, so now we're ready to do this one. We're going to start and say that PQ is a measurement of 6, and ST is a measurement of 6. And it's going to be given. Because those two have the same measurement, that means they're congruent to each other. So now I can say that side PQ is congruent to side ST. And that is the definition of congruence, like the previous problem. So there's it flowing into that one. Over here, the measurement of angle P is 20. That's given to us. 120, not 20. So I know the measurement of P is 120. I also know that the measurement of angle T is 120. So those were given to me. And because of these two statements, I can now say that angle P is congruent to angle T. Also by the definition congruence. So definition congruence works for angles and it works for sides. So since these two statements flow into this one, since they have the same measurement, they're congruent to each other. Okay, remember we need three things to prove that we have congruence, and I only have 2. The last two things are these two angles that we said were vertical angles. So this is angle PRQ. We have to use 3 letters because there's multiple angles here at R. We can't just say angle R. So PRQ, angle PRQ is congruent, that's really bad congruence, to SRT, this angle right here. And we can say that because vertical angles are congruent. Again, I'm abbreviating because there's not a lot of room here. So now I have 3 things proven congruent. Now I can say that the 2 triangles are congruent. I can say that triangle QPR is congruent to triangle. So Q was the blank angle, so this corresponds to S. So S has to be my first one. P was the 120 angle, so that corresponds to T. And R was the vertical angle, so R over here is also the vertical angle. And there I have my congruence statement. I knew that this was true because I proved three things. We're always proving three things are congruent for our triangle congruence theorems. They always use three different pieces of information. So now I can say that those are congruent by angle, angle, side. All right, if you're given the congruence statement, triangle UVW is congruent to triangle XYZ, name the congruent sides and the congruent angles. Well, remember, a congruent statement has everything in the correct order. So this would tell me, as far as the angles are concerned, that angle U is congruent to angle X. So I can say that angle U is congruent to angle X without even drawing the shape. I know that because the order. V is congruent to Y. So angle V is congruent to angle Y. And then I can say that angle W is congruent to angle Z. So because the congruent statement is in order, I now know that those angles are corresponding to each other. I can also do the same thing with the sides. UV is the first two letters. That's one of the sides. So side UV should be congruent to side XY, the first two letters on the other one. Side VW, that's the second and third letters, should be congruent to the second and third letters over here, YZ. And finally, the last side would be the first and the last letter, UW or WU. It doesn't, remember when you do sides, it doesn't matter which order you put the two letters in. And then XZ. Okay, so based on the congruent statement, we can figure out all the three sides that are corresponding and all the three angles that are corresponding. Next one, we've got a flow chart already done here, and we just need to do the reasons. So it looks like starting off here, they've said that these two sides are parallel to each other, and then these two angles are congruent to each other. That's the part that they gave to us. So AD is parallel to CB. They gave that to us with these arrow marks right there. So that would be given. Angle A congruent to angle C. They told us that. That's given. And now they're saying that angle ADB, let's see, ADB is this angle here, and angle CBD, CBD would be this angle here. They're saying that those two angles are congruent. Now, why would they be congruent? Well, it goes back to, see how the parallel is flowing into this one? It means we're going to use that fact that these are parallel. Now, since these are parallel, we can use our angle pair relationships. This is my transversal, and we've got parallel lines. These two are both on the interior of the parallel lines, and they're on different sides of the transversal. Those would be alternate interior angles. So they're saying that these are congruent because when the lines are parallel, alternate interior angles are congruent. And we'll just shorten that and say that alternate interior angles, dang it, stupid light. I'm not moving enough, so my light went off. Alternate interior angles are congruent. And then lastly, they say that BD is congruent to BD. Well, BD congruent to itself is right here. This thing is obviously congruent to itself. But BD exists on this triangle up here, and it exists on this triangle right here. So really what we're saying is BD from the top triangle is equal to BD from the bottom triangle, and that's pretty obvious. They're equal to each other. This is the reflexive property. Reflexive property says that anything can be congruent to itself. And now I've proven three parts congruent: an angle, a side, and an angle. Now, is this angle, side, angle, or is it angle, angle, side? Let's look. The side on the top triangle is not in between the two angles. So this is not angle, side, angle. This is angle, angle, side instead. So this is angle, angle, side congruence. And then Oh, before we get there. So when we do our congruences up here, they don't have to be in the correct order that you see down here. Okay, so this was angle, side, and then an, oh no, it was an angle. Jeez, I wasn't reading it right. They did do it in order, but it doesn't have to be. They put angle, angle, side. I read it wrong earlier. Sorry. So you don't have to put it in the exact order. It's helpful, but you don't have to put it in the exact order. All right, and finally, now that we know the triangles are congruent, they're saying that AB is congruent to CD. Well, look at here. AB is the first and the last letter, and CD is the first and the last letter. On the previous problem, we said that we could figure out what was congruent from a congruent statement. So this is just saying, since I know the triangles are congruent, and this is my congruent statement, I can say that A and B, that side right here, is congruent to C and D, the first and last letters right there. And we call that corresponding parts of congruent angles are congruent, which just means if the triangles are congruent, then any corresponding parts are congruent. Just like we did up here, we matched all the corresponding parts just based on the order. And corresponding parts of congruent triangles are congruent is a lot to write, so we usually just write CPCTC. Corresponding parts of congruent triangles are congruent, CPCTC. It's just way shorter to write that than say corresponding parts of congruent triangles are congruent. CPCTC just flows off the tongue much easier. All right, moving to the next page. Where are we at? Here we go. Next page. In each diagram, determine if the triangles are congruent. If they are, make a flowchart. All right. So these are not going to be drawn to scale, so we can't trust our eyes. We need to trust the facts that we're given. So on this first one, on this triangle and this triangle, they share a side. So this is congruent right there. And then we have parallel lines. So we can say that this angle here is congruent to this angle here. So now we have three things. Is it enough to say they're congruent? We've got an angle, and a side. Yes, those are congruent by angle, angle, side. Because the side is not directly in between the two angles, just like the previous problem. Next one. We've got 5 over here and 4 over here. Those are not congruent. We've got an angle here and an angle here. Those are congruent. They're both 50. And then we've got vertical angles here. And that's all I have. I have 2 angles. Just having 2 angles is not enough to prove the triangles are congruent, so we don't have enough information here. So not enough information. Remember, you need 3 things to prove congruence. All right, next one. We've got 2 and 3 here. And then we've got 6 over here. We do have these angles here that are both 90. And right now, I'm not quite sure if this is going to be congruent or not. I mean, I am sure. I know for sure it's not. But we can use the Pythagorean theorem to find this third side to see if, maybe this side is 6 or this side is 2, which is highly unlikely. But we could do the Pythagorean theorem and do like 2 squared plus 3 squared equals this side squared. So 2 squared plus 3 squared equals st squared. So this would be 4 plus 9 equals st squared. I'd take that and get 13. And then I'd take the square root of both sides. And st would be the square root of 13. So this is root 13. All right, let's do this other side. This would be 3 squared plus 6 squared equals that. So 3 squared plus 6 squared equals uv squared. So this is 9 plus 36 equals uv. We can already see it's not going to work. This is 45 equals uv squared. And this, I would take the square root of both sides to solve this, and I'd find out that uv is the square root of 45. All right, so I've got 2 90-degree angles, but none of the sides, well, we do have one side congruent. On this triangle, we have 3, So we have the reflexive property, and on this triangle right here, we have 3. So with the reflexive property, we have that. So all we have is a 90-degree angle. That's one thing right there. And a reflexive side right there. That's not enough to prove congruent. We only have 2 congruent parts. We need 3. So not enough info. All right, and our last one. For this one, we've got 5, 13. I'm missing this side. Now, if we did the Pythagorean theorem, 5 squared plus x squared equals 13 squared, we'd get 25 plus x squared equals 169. And then I'd subtract 25 from both sides and get x squared equals 144. And then I'd take the square root of both sides. I get the square root of 144, which is 12. So I know that this side is 12. And now look what we've got. We've got a side of 5, and we've got over here, if this is 5, 12, 13, this one would also have to be 5, 12, 13. So this side corresponds to this one. I've got a 90-degree angle right there, and I've got 12 corresponding to 12. So I could use side angle side. I could have also not figured out that this one was 5, and then I would have had 90-degree angle. This is the hypotenuse. And I would have had hypotenuse leg, because 90-degree angle and 12 and 13. We got to do flow charts for these. Yeah, I'll just do them real quick. So flow chart for this one right there. We kind of already did that same flow chart on the last page, so I'm just going to focus on this flow chart here. Again, we had the option of doing side angle side or doing hypotenuse leg. I'm just going to do hypotenuse leg for this one. Okay, so here's what I would do. I've got right angles right here. So I'm going to start by saying that angle L is a right angle. And I also know that angle P is a right angle. All right, so those two things are going to help me prove congruence. Next, I'm going to say that, let's see, I'm going to say that Km is 13. And they told me that QR was 13. That information was given to me. This was given. This was given. All right, because these two have the same measurement, that means they're congruent. So Km is congruent to QR. Okay, and we know that because definition of congruence. Not a lot of room on this to do all this. That's okay. So this statement and this statement create that one. Lastly, I'm going to say that, where am I at? Oh, I proved over here with the Pythagorean theorem that KL was 12. So I'm going to say that KL is 12. And that is the Pythagorean theorem. Wow, I'm really writing small today. All right, and then lastly, PR was 12. And that was given to us. Since these two are equal to each other, that means they're congruent to each other. So KL is congruent to PR. Oops, PR. So these two statements here flow into this statement here. Now what do I have? I've got this one right here, Km and QR. Those are the hypotenuse. I've got KL and PR. KL and PR, the 12s right here, those are a leg. So, since these two statements are saying it's a right triangle, since this statement is saying this is the hypotenuse and this one's saying that it's the leg, I can now say the two triangles are congruent. The triangle KML is congruent to triangle, okay, so I used K, that was between 12 and 13, so R corresponds to K. M was between 5 and 13, so Q corresponds to that. And then finally, L is between 5 and 12, and P is between 5 and 12. So I can say that those two triangles are congruent to each other, and the reason is I had the hypotenuse and I had the leg. Now in hypotenuse leg, you have to prove that you're working with right triangles, and we proved that these are both right triangles right there. So we would say that this is hypotenuse leg congruence. Dang it, stupid light. Why does it keep doing that? All right, so we still used three things. We had right triangles, we had the hypotenuse, and we had the leg. Remember, you could have used the Pythagorean theorem again to prove this is 5, and then you could have used side angle side instead of hypotenuse leg, and that would have worked. In your methods of meaning section, you have just things stating what the reflexive property means that we used today. We didn't really use the symmetric property or the transitive property today, but those will come up in different lessons. So make sure that when you have methods of meanings that you either take notes of it or make sure to mark it in your textbook that you can go back and look at those. All right, that's all I got for today. A little bit longer than I wanted, but there you go. Sorry about the lights turning off. All right, bye.